Good morning, everybody. Sorry to wake you up very early, but we are Thesis Group 11, and we consist of myself, Mustafa Shar'awi, Habib Asar, Nuran Ibrahim, Hamad Basuni, and Omar Alewa. We are supervised by Drs. Hisham Arai and Dr. Sharif Ali, and we are presenting our solution to machine learning and VC evaluation and our product called Fortune. So I'm going to take you through the agenda today. We're going to start with the objectives, and then we're going to take you through the data set and model and our methodology. Then we're going to present our web app solution and provide a demo, and then explain the system design and architecture behind it. And finally, we'll conclude with the business plan, as well as how we believe we've accomplished our empowerment outcomes. So for starters, we have our objectives with Mohammed Bassoon.
At the beginning of the semester, we defined our problem statement to be the process of evaluating a startup is a lengthy process that can be detrimental to its survival, and can be sped up computationally using an ML-oriented application available to VCs. After doing some research and better understanding the problem, we came up with the following statement. Evaluating startups and Kickstarters from an investor or a VC point of view is a lengthy process that can be sped up computationally using an ML-oriented application available to them. The motivation behind the goals that I'm about to mention can be summed up in main 3 points. The first one is that we wanted to enhance VC estimation methods. We aim to better assess the risk, as investing in startups can be considered gambling from VC's point of view, since it has high risk and high rewards. And we also wanted to correctly analyze market size and the company management from their perspective. The second one is to handle machine learning deficiencies as model accuracy issues, lack of available applications, and lack of statistical analysis. These machine learning issues needed to be addressed, as the models can be extremely benefit venture capitals when they evaluate startups. The third one is long time between funding rounds. Every startup needs to acquire funding in order to survive the market conditions. The average time between funding rounds from seed to Series A is 22 months, Series A to B is 24 months, and Series C to from Series B to Series C is 27 months. Our goal concerning the machine learning model is to improve on the existing machine learning models by using more recent data, trying to eliminate the bias in data and to refine the target variable to help reach a closer approximation to modeling the company's success. From our research, we determined the definition of startup success to be the acquisition of Series B funding. We also plan on creating a commercializable product in the form of a simple web application for VCs that will not only filter successful companies, but provide possible analysis to the model's results. We also will present the results from our machine learning model in a research paper where it can be used for future research.
And now on to our data set and model. For starters, the data sets we used were the Kickstarter data set, which had about 300,000 rows, and it had various projects and the information behind them. And then we also used the Crunchbase data set, which had over millions of rows in degrees such as organizations, funding rounds, people, and etc. And while the Kickstarter data set was free to use and like easy to download, the Crunchbase data set actually required a license, and it took some time to get approval for that.
Okay, so I'll take you through. Okay, so I'll take you through. So I'll take you through a timeline of our data collection. So very early on in Thesis 1, we were able to acquire the Kickstarter data set, and we started working on that. We applied to the Crunchbase academic license, but we went through a lot of back and forth with their team. So we started prototyping using the Kickstarter and whatever limited access we had to the Crunchbase data set. We were very fortunate to be able to acquire the academic license by the end of the first semester. So we just moved on to cleaning, merging, and selecting the features from the CSVs to reach our final 2 data sets, which we will talk about later on. And then we moved on to modeling.
As Habiba said, we did some data preparation. We removed the null values, did some general pruning and the likes. And then we also produced our target variable. For Kickstarter, it was whether they achieved the goal. And for Crunchbase, it was whether a company had acquired Series B funding or more or less. So if it had anything less, it would be a 0. Anything more would be a 1. We also analyzed potential inputs through data visualization. We looked at a bunch of research papers and found that many models actually used leakage variables. So we tried to avoid the use of them in our model.
Okay, so I'll take you really quickly through the Kickstarter features. It was around, as Mustafa said, 3,000 rows. It included features like the category and the subcategory the Kickstarter belonged in, the country, and the goal that they reached and they wanted to reach, and the backers of the Kickstarter. Okay, so we had two data sets for Crunchbase. We will be talking about that. One was around 120,000 K, and then one was 1.2 million. It included stuff like the country and the industries and some information about the founder.
And now for our machine learning models, for starters, we planned on using XGBoost because according to research, it was the top model used for binary classification. It was even better than KNNs, SVMs, and logistic regression. And these were the final hyperparameters that we used.
Okay, so we had two versions of XGBoost, which we were talking about in terms of Crunchbase. The only difference between them is one had only features related to the company only, but it was much larger in size, and the other one was had the same features as version 1, but also some features about the company's founder. We just decided to use both just to leverage the amount of data in the first version, since it has way more data.
And then we provided our results for Kickstarter. We did this last semester, and we managed to get a high accuracy of about 93.76% with very high scores in precision, recall, and F1 as well. So we decided these were very acceptable results. We integrated them with the web app, and then we proceeded with the Crunchbase model.
Okay, so moving on to the Crunchbase results, we first started with simple logistic regression. It had very high accuracy, but it had very low recall and F1 scores for like the true class. So we concluded from that is that the model lazily predicted the majority of cases to be false. So basically, it predicted most companies to be unsuccessful. Okay, then we moved on. We then moved on to XGBoost. It had around 89% accuracy. It was higher score than logistic regression, but it also had a similar like problem with the true class with the F1 score and the recall. For version 2, it was less accurate than version 1, but it also had better F1 and recall for the true class.
In order to solve the problem, we actually did oversampling with a Python algorithm called SMOTE. This just synthesized varied entries, it increased the data set and caused each class to have about 50% within the data.
Okay, so these are results with the oversampling. With logistic regression, it was much less accuracy, but the overall scores, it was consistent over all classes. So we were more like confident in our results. So we moved on to XGBoost again. Okay, so XGBoost version 1 oversample gave around 83% accuracy, but it was consistent over all classes. So this gave us like, a feeling, it's accurate. So we moved on to version 2. Okay, so version 2 was slightly less accurate, but it was also consistent over all classes, and it gave investors a bit more idea about the features in the model, so stuff about the founders and so on.
And as a comparison to the baseline, the top chart actually is sort of the state-of-the-art model that we found in research. As you can see, it had higher accuracy and precision, but very low recall and F1 scores because their model also predicted that most companies would just be unsuccessful. And these are our models, version 1 and version 2. While we do have generally like lower accuracy overall by 2 or like 3%, we have much higher recall and F1 scores. So we thought that our model was overall much more accurate. And now we'd like to present you with our solution, Fortune AI, and our slogan, don't wait, evaluate, sorry. Our plan was basically to provide a machine learning web app for VCs to sort of use and like speed up the process of deciding whether or not to invest in a company.
Okay, so we have two types of users. The basic user has access to the Kickstarter model app and is able to predict the Kickstarter success and analyze statistics for improvement. The Fortune Pro user has access to the Crunchbase model app, and they're able to predict startup success and statistical analysis, and it's mainly targeted towards VCs.
And now I'd like to present the system design with Omar Ali.
And now on to our system design. We first started by Dockerizing a Flask Python app that we hosted on a virtual machine. And we had two databases that we used actually in our application, a MySQL one and a PostgreSQL one. We actually used two One for mainly we integrated into our application. It was easier to integrate with our application, and one for backup. The MySQL is the one we used. We hosted them both on GCP, which is Google Cloud platform. And for our front end, we used React JS for developing our landing page and developing a dashboard that is supposed to be accessed when someone logs in successfully into his account. And finally, we used Streamlit library to host our machine learning model. We hosted the majority of our application on GCP. For the backend server, we had the virtual machine that ran Debian 11. It had the following specs: one virtual CPU, 4 GB of RAM, and 10 GB of storage. And for the backend databases, the two databases that we had also around the same specs. And also we had our servers located in Eastern Europe. Western Europe. So it is accessible when someone tries to access our application from the East or the West. And finally, for our Streamlit web app, actually it did virtually cost us nothing. We have a private page that could be accessed when someone successfully logs into his account. The only possible cost that we might be paying later is for having a public domain for our app. Also, we hosted the machine learning model that ran all the machine learning logic and the statistical analysis of our application on the Streamlit library. Now on to our web app demo.
Now let me walk you through our landing page. So when you first open it, there's a home page, and about us and meet the team page. And then the pricing, which has two cards, one for the basic plan and one for the Fortune Pro subscription. There's a contact us page, and then once the user logs in, they're redirected to the dashboard. And now Habiba will be explaining the dashboard.
Okay, so this is a user dashboard. At the very top, they have like the model accuracy over time. Down they have the completed projections and the countries and the companies that they invested in. A bit down, there's just a place where they could place their tasks and check them off. Here's a quick look at the user profile. The company is disabled since we give them access to our product. Okay, so this table is the previous predictions that the company or the user had made. It has all the data that they inputted into the model with the prediction that came out of the model. And then the user can just predict, and it redirects them to the Streamlit web app.
So onto the machine learning application itself. This is the page that the user gets if they're logged in. They just have to re-enter their password. And once they do, they get to select whether they want the Crunchbase model or the Kickstarter model based on their access. For now, we're just going to use a test company. We're going to call it Agri Solutions, just a fake company that provides data analytics for agriculture companies and farms. The company we're going to assume has a LinkedIn, Facebook, a Twitter, founded in 2018 with about a current estimated employees of like 120. The industries include agriculture, software, as well as data analytics. And then we're also going to input founder information. For example, just use myself. Like you're gonna have to enter the name, the gender, and then eventually the degree, whether they are undergoing or like completing a degree, the highest degree achieved, in this case, for example, bachelor's, and then the degree subject, which would be STEM, like computer science. And when we run the model doesn't run once, it actually runs about 800 times. And it sort of varies all of the inputs in order to find sort of the statistical analysis on how to improve or not like improve the company's chances of success. As shown, it took about 7 seconds, and it says that there's a 47.12% chance that this company will acquire Series B funding. And then there's statistical analysis on whether you added or removed social media, how the percentage would change. If a VC were to analyze two of like very similar companies in different countries, they could check which country has the highest chance of success. They could open the graph, save it, analyze it in depth. Same for the year interval, as well as the optimal number of employees. And then finally, you can actually check the potential industries for expansion. You can actually turn on wide mode in order to get a better view. For example, in this case, it says if you add science and engineering or transportation, you could increase its chances by 1 or 2%. And then we have founder analysis on the degree, for example. In this case, if the founder had completed a degree, there would have been a 4% drop in their chances of success, because companies that sort of start earlier have better chances of success as like the founder is graduating. And of course, we have the degree type analysis and subject analysis and how the percentages would vary like them.
Okay, so this is just a quick look at how the prediction that Mustafa just entered just shows up in the simple table. And here has the prediction that we just saw.
Now let me walk you through our business plan. So first of all, we have two target customers. We've decided to segment our target customers into two segments. The first one being individual investors who get access to the Kickstarter prediction model and basic data visualization. This segment is the subscription fee for this segment is priced at around $25 per month. While our second segment is VC firms. They get access to the Crunchbase prediction model. They get to request data metrics and custom data visualization. This segment is priced at around $900 per month. It's a variable quota for each firm, but it's around $900. So for our business model canvas, so let me start by our problem. Our problem lies in the fact that evaluating startups and Kickstarters from an investor or a VC point of view is a lengthy process that can be detrimental to their survival. And therefore, our solution is that we intend to fine-tune the process of venture capital investments and Kickstarters using machine learning models and recent data in order to minimize risk and maximize profits for investors. Moreover, our unique value proposition is that we offer investors tremendous help in deciding whether a Kickstarter is a good investment or not, as well as startups, and thus making them profits with much less time and effort spent on weighing the potential of investment opportunities. Unfair advantages we may face include limited financial resources, but on the other hand, we are the first to deploy this model for commercial use. Customer segmentation, as mentioned before, we have individual investors and venture capital firms. Our early adopters might be, they're mostly firms looking to innovate and disrupt the way they do their work daily. Existing alternatives to Fortune AI, we mainly implement a blue ocean strategy. So therefore, we don't have primary competitors except Capital VX. However, Capital VX does not provide the commercial application for its users. Key metrics we might use to measure success, we could use ROI for investors, as well as comparing predictions with reality after a certain period of time, such as 1 year. Our high-level concept, or where do we fit exactly into the grand scheme of things, we fit into the financial services and consulting industry. Our distribution channels are just one channel, it's through the internet. But to reach a target customer, we will run ads and operate in social media, as well as strategic partnerships with stakeholders. For our cost structure, our cost structure is about $300 monthly for 4,000 users. It's on the Google Cloud Hosting platform. And these $300 are divided into $250 for the database and backend, as well as $50 for the web application. The maximum users on the ML web app concurrently is 256 users, which is currently a bottleneck. Our revenue streams, as mentioned before, is through our subscription model. We have the basic user, which is around, the subscription fee is $25 monthly. And for the Fortune Pro user, it's a variable quota with around $900 monthly. And now I'll be leaving you with Habiba to discuss the empowerment outcomes.
Okay, so our first empowerment outcome is a research paper. We decided to deliver a paper. We titled it Fortune AI, a machine learning application for VC evaluation. We're hoping to target publications like IEEE transactions on pattern analysis and machine intelligence and IEEE transactions on artificial intelligence. Our paper reports feature selection reasoning, model results and performance, and application framework.
And our second empowerment outcome is the commercialized product, which is Fortune AI. We've actually deployed most of our project, including the database backend and the web app for the machine learning, but we have held off on deploying the front end because we wanted to make sure that we complied with all the legal terms that Crunchbase have provided with us, even though we believe that we have. And these are some of the VCs that we've actually tried to connect to. We started with Adventures, who from the start were actually interested in Fortune AI and helping making decisions on potential startups. We've reached out to Qubit Ventures, which were partnered with the Founder Institute, which would help get global connections around the world. We also connected with Shrug VC, which is a VC firm located in San Francisco. We reached out in order to help them as well, utilize Fortune AI because we thought that it would align with their projects. And this was sort of the VC that we targeted to break into US markets. And finally, we plan on reaching out to the Founders Fund, which is a top VC as well in California. And this would help us attempt to break through global markets worldwide.
Okay, so these are our references. And before we conclude, we would like to thank our colleagues, the other thesis students, for their help in the thesis labs always. We would like to thank our friends for always being supportive and hearing us rant about thesis.
We'd like to thank our families as well for your continuous support throughout our sleepless nights working on code, deadlines, presentations, and essays, of course.
And last but not least, we would like to thank our supervisors, Dr. Hisham Arey and Dr. Sharif Ali, for being with us on this year-long journey and provided guidance when needed. And we would also like to thank Dr. Sharif Salema for being a great coordinator and making the thesis experience as seamless as possible. Thank you.